325.
Second stage lock, secure at flight level.
.307. .249.
FTS internal.
CBC locks at flight pressure and flight level.
CBC LH2 at flight pressure and flight level. LH2 at flight pressure and flight level.
.2 minutes. 159. 159.
Vehicle internal.
155.
Launch sequencer start.
Hydraulic pressure. At 4,000.
.140.
FCS launch enabled.
137.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
.120.
OCU's arm. FCS count started.
T-minus
1
1 minute.
Engine start box go.
Rock, report range status.
Range green.
50.
Second stage LH2, secure at flight level.
30 seconds.
Status check.
Go Delta.
Go GPS.
23.
SRM, TVC blowdown.
15.
Roughy ignition.
T-minus
10.
10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and liftoff of the United Launch Alliance Delta IV rocket carrying the GPS-3 Magellan mission for the United States Air Force Space and Missile Systems Center.
Body rate response looks good. Now 15 seconds into flight.
You are hearing the voice of Patrick Moore providing
Main
launch
engine
vehicle
chamber
ascent
pressure
data.
looks good. Seeing good chamber pressure across both SRMs. 25 seconds into flight. Continuing to see good operating parameters on the RA-68A main engine. Chamber pressure on both SRMs continues to look good. Seeing good body rates on the vehicle. Now 40 seconds into flight. Vehicle is now passing Mach 1. Delta IV is now supersonic. Now 50 seconds in. Main engine continuing to perform well, continuing to see a good burn profile on both SRMs. And vehicle is now passing through max Q, maximum dynamic pressure. Main engine continuing to perform well, continuing to see good SRM chamber pressure profiles. 1 minute, 15 seconds into flight. Approximately 15 seconds remaining till SRM burnout. SRM chamber pressure is tailing off. And we have burnout on both SRMs, standing by for separation. And we have separation of both solid rocket motors. Vehicle is now going to closed loop guidance. Body rate response looks good. Seeing minor correction in the roll attitude as expected. And the Delta IV rocket now weighs just 1/2 of its liftoff weight. Second stage ACS system pressurization valve has been opened. RCS pressure response looks good. Now 2 minutes 5 seconds into flight. And vehicle is now passing through Mach 5. Delta IV is now 36 miles in altitude, 55 miles downrange distance, traveling at 4,760 miles per hour. 2 minutes 30 seconds into flight. Chamber pressure on the R-68A main engine continues to look good. Body rate responses also continue to look good. Two minutes 45 seconds into flight. And upper stage lock system has begun the boost phase chill down sequence to begin thermal conditioning of the upper stage engine. Now less than 1 minute remaining in the first stage phase of flight. And upper stage fuel system has begun boost phase chill down. Now 3 minutes 15 seconds into flight. Delta IV is now 65 miles in altitude, 148 miles downrange distance, traveling at 8,500 miles per hour. Now passing 3 minutes 30 seconds into flight. Main engine continues to perform well. Chamber pressure looks good. Body rate responses on the Delta IV also look good. About 10 seconds remaining until booster throttle down. And boosters now throttling down to the minimum power level in preparation for BECO, standing by for BECO. And we have BECO booster engine cutoff, standing by for stage separation. We have good indication of stage separation. The upper stage engine nozzle extension is deploying. We have pre-start on the RL-10. Standing by for ignition. We have ignition and full thrust on the RL-10 engine. Chamber pressure looks good. Body rates look good. Standing by for payload fairing jet, and we have payload fairing jettison.
Delta Mission Control at T plus 4.5 minutes. We've just heard Patrick Moore report the successful execution of the early events of today's flight, and all systems continue to operate nominally. The Delta IV second stage and GPS-3 satellite are traveling in a northeasterly direction up the U.S. eastern seaboard. This mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 9 minutes. Joining me now is GPS-3 Launch Integration and Operations Chief, Major Jenny G. Welcome.
Thanks, Tyler. I'm excited to be here.
Can you tell us a little bit about the GPS-3 mission?
Sure. So GPS-3 is the newest generation of satellites that is required to maintain the GPS constellation, and it's going to provide improved positioning, navigation, and timing services to meet user demands now and in the future. Just to name a few new capabilities, we have the new L1C Global Navigation Satellite System Interoperability Signal. We have higher signal power, greater accuracy, and longer spacecraft lifetime, as well as more signal availability. And there will be even more to come once the new ground control system becomes operational. And this will help GPS-3 maintain its status as the gold standard for worldwide satellite navigation. And you had mentioned before that we were the GPS SPO, the directorate, but at the center we're currently shifting to a new paradigm called SMC 2.0. And GPS-3 is going to be an integral program as we move into the new production core. And that will help lay the groundwork for how we provide improved support to our warfighter through our space capabilities, and how we're going to improve leveraging our partnerships, find new ways to cultivate innovation and decision speed.
So you talked a lot about where you're going, but I'm curious about some of the older GPS satellites. What's the oldest one that's actively working on orbit?
So our oldest working satellite is SVN-34, and that is a GPS-2A that was launched back in October 1993 by a ULA Delta II launch vehicle. So for comparison, GPS-3 SVs have a 15-year design life. This is already 25% longer than the last generation of GPS-2F satellites. Those came with a 12-year design life. So SVN-34, it was manufactured by Rockwell, and it was the 14 of 19 Block 2A GPS satellites that were launched. It had a 7.5 year design life, and so far it's been 24 years and it's still ticking.
Wow. I mean, speaking of the manufacturing, so where's the GPS-3 satellites? Where are they being produced?
So to ensure the most efficient GPS-3 production process, GPS-3, they're assembled at Lockheed Martin's multi-capability GPS processing facility in Waterton, Colorado. This is the assembly, integration, and test location for the entire GPS-3 fleet. That facility was officially opened in February of 2012. It was built in the company's former rocket assembly building. That facility has nearly 50,000 square feet of spacecraft assembly and test area, and it includes a clean room high bay, a dedicated thermal vacuum, and anechoic test chambers. That high bay was designed to maximize efficiency by minimizing the number of space vehicle lifts and minimizes the distances between operations. So just like aircraft and automobile production lines, each GPS-3 satellite will move through a sequential series of workstations for various assembly and integration operations, and it will all culminate with environmental test procedures.
Okay, so how exactly, how dependent is the world on the GPS constellation?
So there was actually an article published recently, June 14th, on Ars Technica, summarizing a study that was sponsored by the National Institutes of Standards and Technology, and that estimated that a complete loss of GPS subfunction would cost the world over $1 billion a day over a simulated 30-day outage period. They approximate that from 1984, when GPS was first made available for commercial use, that GPS has generated $1.4 trillion in economic benefits. So GPS has improved bandwidth and reliability for wireless networks in the telecommunications industry. It made 4G LTE implementation possible with access to highly precise timing. And it has increased efficiency for vehicle dispatch and navigation, which is especially important for large-scale agriculture. And it has made location-based services and apps available for smartphone users. So furthermore, there are new sectors of the economy, such as autonomous transport and Internet of Things, and they continue to find innovative and lucrative ways to take advantage of the position navigation and timing made available by GPS free to the world.
Well, I can definitely say that it's important to all of us. Thank you so much for spending some time explaining it to us, Major G.
It was my pleasure, Tyler. Thank you.
This is Delta Mission Control at T plus 10.5 minutes. All systems continue to operate nominally. The rocket's trajectory continues on a northeasterly heading. I recently caught up with fellow trajectory engineer Zach Henney. Let's take a look. So Zach, as a fellow trajectory engineer, I've heard a lot about GPS, but I know there's a lot more to it that I haven't heard about. So can you kind of explain to the audience today what is interesting about today's flight?
First little interesting tidbit is we're going up the pretty much entire east coast of the United States. Okay. Should be visible through most of the southeast, but we will be hugging the coast all the way up through the northeast, on through the Canadian coastline, and then off and over Europe, and we'll be swooping back down around. We'll be doing our second burn south of Australia, and we're coming into line of sight of an Air Force receiving station on Hawaii. That'll be driving our spacecraft separation time. 25 minutes after we come into view there, we'll be separating the spacecraft. Doing our third burn actually right above Denver. Fortunately, nobody back there could see it because it's during the daytime. And then come back in for a re-entry in the ocean south of South Africa.
So this mission has a relatively short window compared to other launches, but you guys had a clever way of getting more out of that. Can you talk about that a little bit?
Yeah, so it's only 26.5 to 27 minutes that we have to work with. So we're launching every 30 seconds, so at the top and the bottom of the minute to take full advantage of that. And that's really driven by the GPS constellation itself, where we have 6 orbital planes that the constellation is in, and we had to deliver the spacecraft into one of those planes to the target that was given to us by our customer. And to make things work and give us the best opportunity to get it on orbit, we decided to go every 30 seconds and work it like that.
Awesome. So essentially that just doubles the amount of opportunities we would normally have because of that short window.
Yep, exactly. And makes for quirky things like 9 a.m. in 30 seconds.
So I also know that this is your first mission. You know, you've been at ULA for a few years, but you've been working on this mission for a while. Could you kind of walk us through what all of you worked on and how you're feeling about the launch today?
Yeah, so I picked it up 2 years ago this month in August of 2017, where we started with the preliminary mission analysis, which really gave us a good first look at the mission and what we were going to expect going into our more detailed analyses as we moved along. And from there, with every trajectory iteration, just refined it more and more, and eventually it got closer to what we're flying and things started to get real. And then coming out here this week, it was exciting being able to drive up here to the Delta Operations Center for the first time and just seeing the pad lit up in the dark sky behind it, and really sank in that we're launching this bird.
Awesome. So Zach, what's your role on launch day and where will you be?
So on launch day, I'm in the engineering support area here at the Delta Operations Center. I'm on console for flight mechanics, and I'm monitoring the state of the rocket through the various phases of flight and making sure that everything looks good.
Awesome. Well, thanks a lot for taking some time to talk with me. I know you're really busy this week, so really appreciate it.
Yeah, no problem.
This is Delta Mission Control at T plus 13 minutes and counting. The Delta IV rocket carrying the GPS-3 Magellan satellite lifted off from Space Launch Complex 37 at 9:06 a.m. Eastern Time. We're now approaching the first main engine cutoff. Let's join Patrick Moore for mission progress.
In about 20 seconds. RL-10 engine operating parameters continue to look good. And about 10 seconds remaining until MECO. Standing by for cutoff. And we have MECO, main engine cutoff. Body rate responses damping out nicely from the shutdown transient.
We just heard Patrick Moore report MECO 1. The mission now enters a long coast phase. We'll conclude our live coverage in a few minutes, but stay up to date with the rest of today's flight by following our blog. Before we sign off, we'd like to take a few minutes to remember the work done in service to our nation and the world by our Delta IV Medium family of rockets. Though the Delta IV Heavy will continue to launch our nation's largest payloads, today marks the final flight of the Delta IV single-stick configuration. Here's a look at its legacy.
On November 20th, 2002, the first Delta IV rocket lifted off from Cape Canaveral Space Launch Complex 37. Flying in the Medium Plus configuration, the new single-stick rocket had two solid rocket motors for extra thrust at liftoff and a 4-meter payload fairing, protecting Eutelsat's W5 satellite on its trip to orbit. Delta IV development began in partnership with the Air Force's evolved Expendable Launch Vehicle program in the mid-1990s. The result? A family of 5 launch vehicles tailored to accommodate a range of payloads from medium to heavy class. All Delta IV rockets begin with a common booster core, powered by the RS-68A main engine. Solid rocket motors provide added thrust, while the choice of a 4 or 5-meter diameter payload fairing allowed the Delta IV Medium to more precisely accommodate varying payload sizes. Single-stick Delta IV rockets lofted nearly 30 missions to space. The satellites launched by these rockets delivered advanced missile warning, weather forecasting, navigation and communications capability for the Air Force, critical classified payloads for the National Reconnaissance Office, and next-generation weather satellites for NASA.
Good engine control on the first stage.
Though it's an end of an era, the Delta IV's legacy as a workhorse lives on with the Delta IV Heavy. With its 3 common booster cores, the Heavy continues to launch our nation's largest missions to space. Launch of the Air Force's GPS-3 Magellan satellite closes the chapter on Delta IV single-stick rockets, but its legacy and service to our nation and the world lives on in the capabilities it enabled.
I'd like to thank Major Jenny G. and Patrick Moore for their contributions to today's program. For more information about the mission, visit our websites at also our Facebook and Twitter pages, or as I mentioned earlier, our launch blog at ulalaunch.com. We'll leave you now with another look at liftoff of the Delta IV rocket carrying the Air Force's second GPS-3 satellite. I'm Tyler Strickland. On behalf of the entire launch team, thank you for joining us and have a great day. 10, 9, 8, 7, 6, 5, 4, 3, 2, we have ignition. And liftoff of the United Launch Alliance Delta IV rocket carrying the GPS-3 Magellan mission for the United States Air Force Space and Missile Systems Center.
Body rate response looks good. Now 15 seconds into flight.
You are hearing the voice of Patrick Moore providing launch
Main engine
vehicle
chamber
ascent
pressure
data.
looks good. Seeing good chamber pressure across both SRMs. 25 seconds into flight. Continuing to see good operating parameters.